Hello friends, you're welcome to the part 1 of building a REST API using Rust and the Axum framework. In this part, we'll look at how we can use the Axum to design a REST API. Without much delay, let's get right into it. The first thing to do is to use Cargo to create a new project. Think of Cargo like your npm package for your Node.js application. You can check if you have Cargo by doing Cargo version. And if you see an output like this, it means that Cargo is installed on your computer. By the way, it comes shipped when you install Rust on your operating system. So I'll do Cargo new, and the name of the project, I can do Axum projects. Okay, I have another folder named Axum project already, so I'll do Cargo new Axum Pro, like so. And this will create a binary. It will create also a file called cargo.toml and other definition that can be found in this link here, right? And if I do ls, if I go into the axum.pro folder and I do ls, we have the cargo.toml file and the source. If I go into the source and do ls, we have the main.rs. All right, you can open this in your preferred IDE. I'll be using my nvim to open this. And in the main.rs, we have a function called main, then a macro. So anything that has this exclamation mark is called a macro, and it's not just a function which prints hello world. Then two ways to run this app. If I open my terminal, I can do cargo.build. So this will create a build in the target folder. If I open this and I go to debug, you can see the build here. So you can run it by doing target, then the name of the app, Axum, target debug, and Axum Pro. So we have the hello world. So you can build first, then you can run the binary. Or a much faster way is to just do cargo run, which you build and run the binary. All right. So let's go back to main topic of this course. We have the Axum framework here. You can just go to your Google and type Axum Rust and choose this first link, and you have this great Axum. So let me zoom in a bit. Axum is a web application framework that focuses on economics and modularity. And to use Axum, this is the main code. You have to install the package. So let's do that right away. I'll close this. I'll close my target, my source, and go to the cargo.toml file. You can install by typing Axum, and you can give it the version that you want to install, 0.7, 0.6, 0.9, as you wish. Another simpler way to install is by opening your terminal and write cargo add Axum. And this will pull in the crate or the codes that you need to use Axum. And if I go back to my log and come back to my toml file, we have the 0.8.6 version installed. All right. To write the hello world of Axum, we need to import this Axum, the routing, and this is the get method, and also the router. It's very similar to Express. We are coming from the Node.js world. So we bring in Express, we declare the router, and we use the app.get or .post. So if I copy this, and I will paste it here, and I'll save. So let's read one by one, or let's remove all these errors first. So to remove this error, we need another create. As you can see, fail to resolve use of unresolved module or unlinked create Tokyo. So we need to bring in Tokyo too. If we go back to the documents, it says we need to add Tokyo features, macros, and so on. So we can copy this and open our terminal again and just paste. And let's save, and the error is gone. So let's explain this one by one. We'll do my Control K. So Axum is a web framework used for routing requests to handler with a macro free API. It's simple and has a predictable error handling model, blah blah blah. And this is also how you can use Axum. And what is Tokyo? Tokyo helps us to run. It's like a runtime. Think of Node.js. Node.js is a runtime, and Tokyo 2 is a runtime for writing reliable network application without compromising speed. And what you need to take notice, it's an event-driven, non-blocking I/O platform for writing asynchronous application with Rust programming. So it helps us to write asynchronous programming, in short. So think of Tokyo as a runtime that helps us to write asynchronous programming. So the next thing of interest is this router.new. We have this router and this new keyword. The new keyword helps us to create an instance. So it will create an instance of a new router, and we are calling the route.get. So this get is a method. We have the get method, the post method, the patch method, and whatnot. Then we have this closure here, this double pipe. Think of your callback function in Node.js, where you can do something like this. App.listen. Then we have a double bracket here, and we have something like this. So it is equivalent to what we have in this double pipe here. Right. So this double pipe can also receive a parameter. Like, so say something that you want to pass into this get function. And we have this async keyword, and we are returning hello world. Right. And this is a path separator. It helps us to access functions and method in an instance. And also we have this Tokyo, this runtime. Then we call the net, which contains the TCP and the UDP networking types, and the TCP listener. So this one is a TCP socket server that listens for connections. So just listen for connection. Think of your WebSocket listening to receive and to emit data. And the bind method, the bind method will bound to the specified address which we entered as 000, and with the port 3000. Then we await, we are using the word async here, then we need to await it, then we unwrap, which returns a value. So the unwrap returns the contained OK value. So we have, this is the value, demands the result, which is the value and the error, and this returns the value. All right. And at the end, we have the axum.serve, which takes in a listener and the app, which is this make service. And we also await and expect the value. I hope that makes sense. And if I do my inlay, so the app is of the return type of router, and we can see the path here, the method router, the handler. So this is the handler, and this is the path, which is /, and this is our listener, which will return the TCP listener, and this is the address, and this is the make service that I showed earlier. So I'll remove my inlay service, save this, and open my terminal and do cargo run. And just a point to note that cargo build or cargo run might take some time to compile, unlike languages like Golang, but at runtime is very, very fast. So we have the cargo run here, and we have target in 0.06 seconds, and let's print something with a macro. After connecting, we can do print ln and do server running on port 3000, and we need to end with a semicolon. And let's do the cargo run again. So if you had any changes to your code, you build your code again and run, unlike if there are no changes. So let me just demo that. We have server running on ports, right? And if you notice that we have Axum pros, blah, 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 compiling here. But if I do Ctrl+C and do that cargo run again, you will not see the compiling again. So server running on port 3000, and let's go to port 3000 and just run this, and we have hello world. Cool. The next thing to note is how we can have our handlers. So how we can separate concerns instead of mopping everything inside a router here. We want to extract this closure out into its own function like this. So we can have the hello world extracted out. Come here and do a sync, then a function, call it hello world. You want to use the snake case, I'll call it handler uses snake case. So, and we want to do hello world, and this should return a static string, and the error should be gone. And we can remove everything here and pass in our hello world like so. And let's build a running cargo run, so we compile again and we run the binary. And if I come back here, everything should still work as expected. Another point to note is this chaining. You can chain your get and your post. For example, you have a user's endpoint here. You can do user.get, which we call this handler, and user.post, which we call this. So let's try to write that. I'll put my post here, and it will be, I'll do hello post like so, and we can just duplicate this and paste here, and we call this hello post like so, and everything should still work as expected. Right. And this brings us to our next topic, which is extractor. There are a number of extractors that we can use with Axum. We have the path extractor, we have the query extractor, and of course the JSON extractor. So let's start with the path extractor. So if you want to write endpoint with a path variable, For example, I want to pass my ID here, the ID of 1 or ID of 2. You can use the path extractor here. Let me post this. So I'll come here and write extractor and for this path extractor call it async as function. Let's give it a name, call it path extractor, and this will taking a path from Axum. We have the extractor that we get captured from the URL and passed it them using SEDI. We'll talk about this SEDI in a while. And with the path, let's call it user ID, and the return type should be path, and in this, then we pass in the data type U32, that is unsigned 32. Unsigned means that it cannot be negative, only positive. And we need a return type. This will return a string and return a format. So another way of printing or sending something out is by using this format. And the user ID is return a user ID. So, and we close this. Oh, and the beautiful thing about Rust and the Rust Analyzer, which is the LSP, is it will show you when you have errors in your code, saying remove this colon to return this value. So if I remove this, and the error is gone. Cool. So let's use this path extractor. I'll come here and break this down, go to the end and write another route. And I'll do user ID. So the old way of, I'll show you the old way and the new way of doing it. The old way is by using user ID like so, and you will pass your path extractor. So this is the, by the way, this should be in the get and path extractor, and close this. So this is the old way of writing it, and the new way is copy this and paste, comment it out. New way is using a bracket like this, a curly bracket, and you can pass in the, so just in case you are using a lower version of Axum, you find yourself using the colon user ID, or you can use this curly bracket. So let's use a well, compile, build, and up and running. We can go to the user ID. I'll type user here, and I'll put 90. So the user ID is 90. So this is how we can extract our path variable from the URL. So the next one is to look at the query extractor. Let's put it here. I'll do the query extractor. And the difference between the path extractor and the query is the path we use something like the colon, while a query parameter we use the question mark. You can do question mark and something like a page. Then you can do 9 and something like limit, right? As true. And to write a query factor, I'll do async. In a function, you can do query extractor, and this one, instead of using the path, we use the query from Axum. It serializes query string into some types. That's what we are looking for, and then passing the params, and the return time will be of same query. Then we can use hash map. Hash map is just like objects in JavaScript. So this should come from hash map. And we can do string of string. So the key should be a string and the value should be a string. That is the meaning. Just like a key value pair. And this should return into response from Axum. And we can also use this format. That should be a macro. Explain macro. We'll have this exclamation mark. And format is just used for creating string interpolation. If you want to pass in data dynamically, we use format. And do query param is, and if you want to print out collections or stuff like hash map, we use this colon and question mark. For example, you want to print out a list or slice, we use this question mark. And if you are printing out primitive data, we use only this curly bracket. And passing the params, you need to close the, and no need to add the semicolon. So let's use this. I'll come here and I'll create another one called route. I'll just query. And query we can get, and we have the query extractor. Close this. So let's save and let's run. You're up. So if I pass my query and the query param is empty, we return into response. This implementation, so which can be returned for handlers. Let's read about into response. So this into response straight helps us to convert any function that we want to return into HTTP response to the client. So that is what we have here. So we have the query params empty, but if I use query params, and let's do key equals to 18, you have key equals to 189, and let's add another one, age equals to 90, you have age equals to 90. This is how you can extract data from your query params. All right. And lastly, we have the JSON body. So we can pass our JSON into our function. So let's do that. So I'll come here and I'll type this to body, right? So async, and then we can do body, or let's call it request body, for lack of better words. I'll use the JSON and Axum. So this, it can deserialize, that it converts the request body into some. So when you use an extractor to deserialize, that is converts the request body into some type that implements the SEDI, would install this very soon. JSON and have a payload, call it payload, and type be a JSON of a struct of user. We'll declare the struct very soon. I say let's the response was to user. Let's quickly this. So let's define a struct of user, or do struct user. User should have a field of name, which can be a string, age, which can be U32 or 4, and can do install. Again, I want to use snake case. So this is our user, and Rust Analyzer is saying that we need to include these fields. The missing fields are age, install, and name. Cool. So we can do name equals to string from, I'll do mi and age. I'll say 12 and install to be true. And we need to end this. All right. And to return this response, we can use the JSON, and we pass in the RS2, and we got this, error that found struct mismatch type, especially the unit type found struct. So we need to, and it gives us a clue, try adding a return type, Axum JSON user type. That by coming here and by passing JSON, then pass the user up here, and the error is gone. And by the way, you can also extract it from this. Instead of using this string, instead of doing an hard-coded value, you can do something like payload dot name, like so. But for the sake of simplicity, let's just go with this hard-coded value. All right, so let's call this by, then we paste and all this JSON request body. This should be post first, and we end so. And it's saying cannot find post in the scope, not found. So what is saying that we need to import the post request. And if you notice that we are using this separator to just get the get method, but if I bring in the post, it will be destructured. Let me get the post from Axum. You see, so we have this structuring, we are getting the get and the post from it. So the last thing to do with this request body is to deserialize whatever we're passing to Axum here in this user struct. We need to use the derive derivatives, and we're passing the serialize and deserialize keyword. So if I go back to the note, let's look for, can we see 30? So 30 or said, I don't know how to pronounce it, for serializing and using Rust data structures efficiently and generically. So we use this crate. So let's install it. So I have it here. I'll paste and we do, I'll go build like so. Let's give it a while. All right. And we go back to our main.rs and we can denote by just passing derive and how do you serialize from the serialize. And the error is gone. So you just need to pass this serialize macro and the error should be gone. So let's test this. I'll rebuild my app. I'll go run. And we're getting this warning because we did not use the payload from the request body. That's fine. I'll create a client.http and this will be a post request http localhost. And I think it's 3000. And what is the split and go to the main? It's JSON. Yeah, I'm gonna have a content type. And do content type as application JSON. And we can have this. I do a restaurant. Yep. And we have this sense. So this is how we can receive data through the request body. We have the name, the age, and the store. Oh, so we have covered the common ways of extracting data out of the URL, the request body, and the query parameter, which is what we're going to be using in the next class to access data from our DB by using the CRUD operation, the create, read, and update operation. So in the next class, we'll be connecting to a Postgres database and playing with real data. This brings us to the end of the part 1, and if you enjoyed this video, please do well to leave a like and subscribe to the channel, and I'll see you next class. Thank you.